Hello, and I've been having some fun with AI and particularly getting it to generate stuff that it shouldn't. Case in point, what you got in front of you here is a rough copy of the red line stealer. It's a very common malware that if you get like lovely ladies in your area phishing messages where it's click on the thing, odds are they're going to be trying to install the red line stealer of some shape or form. And what I did was I got ChatGPT and GitHub's Copilot to write it for me. It was surprisingly easy to get it to do. And so the code, I've just got it written in Python. I want to try it in lots of other languages, see how well it does. But I've had some upgrades to my lab since the last video. And so I wanted to show both the code and the new lab setup and some of the other detection stuff that I've gotten. So I've gotten rid of Defender, Microsoft Defender, and I'm now using Elastic Stack Security, and I have it set to be super twitchy. So I'll be curious to see what it finds and what it can't, but we'll show that in a minute. So I've got, this is my victim machine. So this is the Windows VM that I'm going to be abusing. It's going to run, this is the malware here, the client.py that I'm going to show you in a second. And it's going to run that, and it will we'll then see if anything gets picked up, and we'll also see if the code runs, because I haven't actually tested this code yet. This is straight basically from AI, a little bit of debugging for formatting and things like that. But I mean, you can see we've got libraries that aren't being called yet. These ones are grayed out, they aren't used, or they're not. Yeah, they're not called. Yeah, I don't think they're being called. And so I'm going to do a quick run through the code to show you what it's doing. It's sort of how it does a few things, and then we'll try and run it and see how that works. So the first thing that it's doing is going to try and create persistence. So it's going to take the path to the file that we want to run every time, whether it's likely going to be a separate file. What I would do is I would have this be the initial thing that runs to infect the system. It'll pull down something like a reverse shell or a C2 beacon. I can show you, I actually got it to create one of those as well in Rust, which is very, very cool, and it works really, really well. And then have it inject itself in here. So this is specifically for Windows, this one, because it's using the Windows Register. There's plenty of other stuff you could do for Windows. If you're interested, I'll talk about persistence in in Mac OS and Linux and stuff, because it's very cool how you can do that. So this one is just adding the registry key to pass basically the path to the malware here. So line 26. You pass it the path to the malware that you want to run. Probably don't name it malware. And then it's going to run that just directly after. So you see, it's even told me example usage. That was nice of it. So it's going to try and do that. I am assuming that sets off alarm bells. It must do. Fiddling with registries like that, I'm going to assume that triggers some sort of warning. And then here we've got some defense evasion. Is it a sandbox? So it looks for particular artifacts. Dismiss that. So it looks for particular artifacts in the system to see if it is potentially running in a VM. So in theory, this code should not run because it is a VM. I should need to comment this out to get this to run in theory, but we'll see. So it's, where are we? It's doing that through the get invan path. So it's looking for anything in the path that looks like this in the get environment. So actually, I don't think that's going to pick up, but we'll see. Here's another thing. I'm talking to it about how it does other defense evasion things, and one of them was executing Python code in memory. So in here, this is very, very simple. It's printing, executing Python code in memory, and then you put in what you want in here. That's it, and then it's using exe to run that code. So really, what you would do is you would have a small payload that just calls a bigger payload. So you would have like a stager. So this client.py, client, I spelled client wrong, I just spotted that. This client.py would be the main chunk, and you would send something down first that would then pull this file down and then run it through this function so that it runs in memory, so it's never touching the disk. We're not doing that right now. We'll do that in another video when we talk about defensive agent stuff. But just I kept it in here because it's a cool thing, and I'm curious if that gets picked up. Even though it's not running much, the fact that it's calling something into memory might be suspicious. And then here is the meat of it. This is where we are gathering information. So the gather information function is the main one, which is why there's a couple of calls in here, like the execute memory in Python is called, and checking if it's a sandbox. And then it goes through and gathers some information. So it gets any platform information, host name, architecture, gathers user path and login information, then tries to grab some data off the browser, so cookie information or anything like that, or any credentials that it can find. At the minute it's just doing history and cookies. And as you can see, ChatGPT has been very kindly said, add more browser data paths as needed. So in there you would have, trying to find credentials or poorly secure or things like that. And then trying to pull down some sensitive information. So on Linux, that's the passwd file or the shadow file, and then Windows System 32 into the SAM file to try and pull some sensitive information there. Again, it's like, oh, you could add more to this. I did try and get it to add more, but it was a little bit wishy-washy, just sort of gave the same information back. So I want to tweak and see if I can actually get this to just full-blown write everything that it needs. But I mean, at the stage, this is fairly sensitive information, and it would be really easy to pull down, a reverse shell, a rat effect, or turn this into a rat effectively, by doing the executable, especially if this doesn't get picked up that this is being done. So we'll see. And then here we're then transmitting the data to a C2. So we're then sending the information back to a server that the attacker has control of. Basic C2 request, a basic request, post request, just sending data out, easy as that. And then down here in the main, we're passing it to the C2 endpoint, which in this case is going to be this machine that we're on now. I'm going to set this up as the C2 server. It's then going to gather the data and then transmit it to the C2 server. It's as simple as that. The actual server file is even more basic. It's literally just using Flask, and it's just set up an endpoint that's going to receive post information, and it will print any data that's found to the screen. I may need to redact that depending on what gets put back, but we'll see. So this is what I'm going to run here. I've got a file server run a web server. This was just to get the client onto the victim machine. So if anyone doesn't know, down here you can do Python -m HTTP server, and that sets up a little web server that you can use to transfer files between machines quite easily, if anyone didn't know. Now I'm not sure if I have Flask running, so let me just check that. Okay, yes, so I had to install it, but got it installed, and now it's just you run it by running Flask --app, the thing that you want to run, and then the host 0.0.0.0. That's basically saying that it's accessible on the network. If you left that out, it would only be available locally because it's sort of meant as a dev server, and so that means it's able to be ran wherever. And it's being served on port 50, so let's just double check the client is doing that as well, and the IP address matches up. So 192.168.1.152, 192.168.1.152 :50/C2 endpoints. Cool, happy. So what I'm going to do now is on here, I'm going to run Python and run this client py. I have no idea if this is going to work. Okay, so I may need to do some debugging. I haven't ran this since pulling it in, and then I also want to see what alerts on Elastic Stack and see if anything triggers off, because it's quite an aggressive little script. So hopefully should pick up a few things. So let's run this and see. So Python or Python 3. What do I need? Let me see. Python. So I want to do Python, and then just pass that. Error, doesn't like something. No encoding declared. Okay, let's debug this. Okay, so there was some formatting weirdness going on there. It had went down in a different file format or encoding or something. It was weird. Got that fixed, so let's see. maybe. Yep, of course, missing modules. I need to install requests. Let me just check the top of this. What else would I need? Subprocess has a built-in C types. I think WinReg is. I'm not sure what platform. I think request is the only one that's external needs installed. But we will see. So we'll install that and try that again. Yeah, so yeah, we just needed requests, and it started running. But look, freaking Elastic Stack spotted it. It's awesome. Okay, so it's saying it successfully created the persistence mechanism, so we'll check that there's actually a registry in there. Executed code as memory, that's fine, and then transmitting data, maximum retries, abort caused by an SSL error, wrong version number. Interesting. I don't know how much that is down to a connection issue, or whether Elasticstack killed it before it could get any further. I'm really curious what the alert's going to look like. So because it stopped it, it will alert in the dashboard. If I pull that over and see, we should see the alert come in here. It can take a wee second for it to come through, but once it does, we'll take a look and see what the alert looked like. Actually, do you know what? While we're waiting for the alert to go through, I'm kind of sad that he's missed what it looked like when it ran. So I just sort of ran it and thought, oh, we'll hit another error, it'll be fine. So let me just run that again, and there it goes, straight away. Boom, malicious behavior prevention alert. And this time it didn't actually even get to the transmission. We do notice here that it did try and get something. So the HTTP status bad request. So it did, something came out to it. It just was malformed. Again, whether that's down to the code or whether that's down to Elasticstack killing it, I don't know. We'll need to debug it. But here we can see it didn't even get that far this time. It stopped it, and I would say it's probably one of the things that it was doing of like looking through the information to pull back relevant or sensitive information. It's going to be one of them that's triggered it. What would be really cool to see now is if we take this and do that sort of stager. So we have one Python command that's quite low that then runs the main one in memory and see if it still gets picked up. What we'll do while we're waiting for the alert to actually trigger is we'll check in the registry and see if that file path got added. Right. So we've got registry open here. For anyone who doesn't know, if you go here and go regedit or reg, you can get the registry editor. Let me double check what path that was going to go into. So it's under HKey, current users, software, Microsoft. Okay. Let me pull this over to the side so I can see the path. So we would have been under current users, software, it's here, Microsoft, in here, and then Windows, current version, run. And there it is. Look at that. So it still managed to add into the registry. So Elastic, the AV didn't see that as malicious. Which in fairness, it's not actually a path to anything. So what we'll maybe try and do is get the stager that's going to run it in memory, and then have, and then have other things. So yeah, what I'm going to do, I'm running out of time of recording here, so we're looking at the alert as the last thing I'm going to do today. But what I'm going to do is I'm going to expand this out and make it sort of more multi-stage so that you have the initial one that tries to run it in memory to see if that evades anything. And we're also then going to get it to put into registry a reverse shell, so that then we can get access back into the machine. I'm not sure what I'll write that in. I'll do something, and then we'll see if then if it picks it up, because I think maybe I would have thought it would pick up fiddling with the registry, but there is a lot of legitimate reasons why systems would do that, or why some things would do that. So it's not, ridiculously this is sketchy. But what I'm thinking is that the EDR system, the malware prevention, is going to pick up on the execution of the reverse shell. Or actually, I've got a C2 beacon. I'll probably stick a C2 beacon in here and have that running, seeing as I've got got some code that again was helped written by AI, which is outstanding. So I'll stick that in. It's written in Rust, and so we'll see then if it picks up that kind of activity. I'll maybe make just a generic reverse shell as well, just to do both. Now let's go over here and let's refresh this and see if this has been picked up. That definitely looks like it has. So let's see. So these two were from earlier on today. Yeah, these two were early on today when I was testing. So this one, let's get more details on that. So first time scene driver loaded. Let me see, alert reasons, system. See if it gives some information about it. So this is actually quite nice. So Elastic have not paid me to use this, by the way. They have a free trial. I am going to reach out to them to see if they'll maybe give me access to this cloud thing for these videos. But yeah, just they haven't asked me to use this. It's just quite a cool tool. But they had a little button in here, show investigation guide, that then gave additional details about how to triage it, how to analyze it, which is really nice. And from that, I think what's actually happening here, this was the execution as code, or the execution in memory is what this picked up. Is Python running that simple print hello world in memory is what this picked up. So it did actually see that. Now it didn't stop it. So there's different levels of alerting and detection response. There's only certain times when it will step in and say, no, I'm going to stop this from happening. I've left that on because I'm curious where it stops it and where it doesn't. But this is one where it's seen it and it made an alert. So in an enterprise environment, this would go to an analyst. An analyst can then look at that and go, okay, is this suspicious? Is this a DLL, or is this something that we've used before, or is it not? And then in this case, obviously it was malicious code. So that's quite cool that it picked that up. Let's see, and this malicious behavior prevented. So this is the bit that actually kicked off to say, no, I'm going to stop this. So let me see what it was that actually flagged. It seemed that it was Python. It was the registry keys. Startup persistence spam windows. Yeah. So it was actually the editing of the actually editing the system keys. So it didn't stop it from editing. It must have just not been in on time. Maybe it didn't get a chance to stop it. I wonder, does this have any information? I like the risk scores. I'm going to see if this actually gives information as to what the registry was that was edited. Yep, and it does. So it's here in the JSON output that it's given the path, the event registry path that's actually put in. So fucking awesome. So it picked that up and it killed it based on that. So I wonder. Oh, interesting. I didn't even twig. So yeah, the evasion for sandbox evasion doesn't work. If we go back to here. Or is sandbox, that doesn't work because it's in there, but it obviously still ran. But that's quite interesting that that's what killed it. So I wonder if then how do we obfuscate that? How do we not get picked up by editing that? 'Cause I wonder, was it the editing, the creation of a new one, or yeah, a bit of fiddling to do there for the next one. And then these other two are alerts, just based on startup run or registry key modification. So I think these are part of different rules. So whenever I went in and set this, I turned all of the rules on, the whole heap are on. So because I wanted this to be as noisy as possible, like I want to see as much information as this thing can see, so that we can tie it back and make life difficult for ourselves, because why not? Let's try and make it a good fight. And you see this is given information here. So again, in an enterprise area, you may not have this directly block some of these things. It may just alert so that an analyst can see. So similar to the running in memory, it's seen it, but it didn't actively block it, and we can configure that. So this alert obviously based off a slightly different rule. It picked it up, but it marked it as a low, and just alerted on it for an analyst to then take a look at, which is quite interesting. And there's quite some cool stuff in this. So you can see that it's even given the MITRE ATT&CK drop down of the types of persistence that it's doing, which is quite cool. And then the reason for the alert, all that good stuff. So yeah, lots of good information, and got caught. That's cool. So yeah, what I'm gonna do is I'm gonna do work on the code a bit more, and add in a stager so that I'm running this in memory just to see if that tweaks anything else. I'm gonna see what other persistence things we could do, or see if there's a way of editing the registry key, but in a way that doesn't trigger this, and then also try and put a C2 style beacon on this, or a reverse shell. Just before we call it, I will give you a quick look at the C2 agent. So this is written in Rust, again using this was using Google Copilot. So I started writing it and then used it to like fill in gaps, which is really good for learning. Like I love Rust as a language, but some things can be a bit convoluted. Like using the Git Copilot made this so much nicer. Just being able to just go, you can highlight like a function here and do, I believe it's apply, and then you just say explain, and it will explain how it works. It is really fucking handy. So it was built using that, and I think this is the C2 beacon that I'm going to put on, or going to attempt to put on the Windows box. And this just does at a random interval between 5 and 60 seconds, it pulls out and sees is there any commands waiting for it to pull down. The server side of it, or the controller, it's basically an API almost, or a web interface. So I can send a post request to this to add commands into the stack to be pulled down, and then the C2 beacon reaches out to it and pulls that down, and then gets the okay. I'm going to make a web interface for this. This is so much fun. So I started writing this as a bit of a haha, look what I can get AI to do, and then when I seen how I could do it in Rust and the sort of ways that it's quite easy to do these post requests and things, especially using Warp, I was like, do you know what, I'm going to make this. I'm going to make this into an actual thing and get a web UI for it and all that good stuff. So I'm going to build this out, but I'm going to use this as the beacon that we're going to put into it. So yeah, but yeah, if you have anything any ideas that you want to put in, anything that you think that I missed, or any cool features you think that would be cool to add into the malware or staging or anything like that, let me know. I'm away for training on Monday, so I'm gonna come back with loads of stuff. Hopefully that we'll be able to do some cool stuff together. But yeah, if you like this stuff, let me know. If you don't, also let me know, and yeah, we'll see you later.